Principle of the parallel DC power supply system. The parallel DC power supply system is a type of DC power system that adopts a parallel power distribution structure. It consists of battery modules and parallel power modules, forming independent power units. Unlike traditional series power systems, which use a single set of batteries, the parallel system divides the battery group into multiple smaller groups. Each group is paired with a dedicated parallel power module to form a power unit. Multiple power units are then connected in parallel to output to the DC bus, creating multiple power supply circuits. This structure changes the traditional single-circuit power supply method of series DC systems. When a single power module fails, it does not affect the overall system power supply, thereby significantly improving system reliability. Operating mechanism of the parallel DC power supply system. The parallel DC power supply system adopts a three-level power supply mechanism, including primary AC, DC power modules, standby DC power modules, auxiliary freewheeling circuit. Level 1. Normal operation. During normal operation, the AC-DC rectifier module converts AC power into DC power to supply the DC bus. The parallel modules draw power from the DC bus to charge the battery modules. Level 2. Insufficient DC bus power. When the station AC power is lost or the AC-DC modules fail partially or completely, causing insufficient power supply to the DC bus, the bus voltage drops to the discharge set point of the parallel module. At this point, the battery module boosts and continuously supplies power without interruption. Level 3. Emergency backup power. If both the AC power, AC-DC modules and DC-DC modules fail, resulting in further voltage drop on the DC bus below the voltage threshold of the freewheeling circuit, the freewheeling circuit activates as an auxiliary power supply to maintain critical operations. Principle of battery capacity verification in the parallel DC power supply system. The parallel DC power supply system adopts a grouped power supply architecture, with each power unit operating independently. It supports online full capacity verification at 0.1 C discharge rate and allows users to preset parameters such as discharge depth, cutoff voltage, and automatic verification cycle. When one module performs capacity verification, the parallel module increases the bus side voltage, enabling the system to discharge to the bus load without requiring external discharge equipment. The parallel module controls the battery side to perform a constant current discharge at 0.1 C for capacity verification. After one unit completes the verification process, the system automatically generates a capacity verification report. Once a module's verification is completed, the system sequentially initiates the next group's verification. Capacity verification can be controlled either manually or automatically, and operations can be performed locally or remotely. Connectivity testing of the parallel DC power supply system. In cases where batteries have internal open circuits or connection issues such as open circuits, loose connections, or poor contact, high current discharge during operation and maintenance can detect these faults or accelerate the fusing of fault points, thereby identifying potential hazards. This ensures the safe and reliable operation of the DC power supply system. Detection parameters can be set on the monitoring device, and related control operations can be performed to generate a connectivity test report. Battery bypass function in the parallel DC power supply system. The parallel module is equipped with a battery bypass function. When an individual battery cell within the module experiences an open circuit, the freewheeling circuit can bypass the faulty battery through the internal bypass circuit of the parallel module. This ensures that the freewheeling circuit remains connected to the bus and maintains the system's output capability.